Hi, in this video we will see how to build a multi-document agent which is able to read different research paper and able to query. So there are now two kind of query that can be done on a research paper. One is like you enter a question and it will answer you, and second one is a summary tool. For whatever query you have given, it will give you summary of that query. So starting with, first you have to enter your OpenAPI ChatGPT key. Then you have to import nest async IO for asynchronous operations. Then we can see like we have given three URLs and name of three different papers which we need to query on. And in the next cell we can see like we are just looping over the papers and saving vector and summary tools to a dictionary. Now to know like what is happening inside get-doc tools, we will go to the another file utils, in which we can see the definition of it, and inside this we can see it is taking the file path as name. So all the research paper that were present are already downloaded into the file system, and then one by one for every research paper we are creating two tools. One is the vector query tool and other is the summary tool, and we are just returning it back to the function. So the vector query tool is the one which will be used for question answering, and the summary tool is the one which will be used to create the summary of the query. So this is the function that we are using over there. Coming back to our main code, so then we are creating a list of all the papers that we have saved in the dictionary. Then we can see like we have specified which model of GPT we are using. It is 3.5 turbo, and then we are creating an agent worker with all the initial tools. So as you can see, the length of the initial tool is 6. So if you are using 3 papers, so there are going to be 2 tools for each paper. One is vector tool and other is the summary tool. Then we can see like when we are if we want to query the research paper, for example, tell me about the evaluation dataset used in long LoRa, and then tell me about the evaluation results. So it will automatically find out of which paper we need to extract that information from. In this case it is long LoRa.pdf, and then give us the results. So as we can see, when we run this query, what kind of results we are getting, and also it will tell you which tool is being used to answer this query. So in the first one, tell me about the evaluation data set of long LoRa, we can see vector tool long LoRa has been used, and in the second query for the evaluation results, again the same tool has been used. Now again the another query, give me a summary of self-RAG and long LoRa. In this case you can see there are 2 research papers that were queried. So it should be using 2 different tools now. So first is the summary tool for the self-RAG, and second is the summary tool for long LoRa to answer the query. Now what if we want to query multiple papers, not just 3 but 11? So because of the limitation of context size, it is very difficult to load all the papers in the memory. So there's a different approach that we are going to follow. If we want to load more than 3 or 5 papers, it could be 20 papers, it could be 100 papers. So for this, what we are going to do, we are also going to create a vector tool for the function itself, which is like retrieving the query output. So for example, right now as we can see, like we have loaded up 11 research papers over here, and we have saved vector and summary tool for all those 11 papers. So we can see all tools are now in all tools. It's a list of 11 papers with all the tools. Then now we have created a object index. This object index consists of all the list of all the tools, and what we are going to do, first we are going to retrieve this object index based on the query, and then we are going to summary or query the actual paper. So this process will reduce the context memory. We don't have to load all the paper into the memory. Only the top 3 paper will be loaded first, and then it will be queried instead of loading up all the papers in the memory. So here we can see from tools we have specified the object retriever, which will select what tools to use from this list of all tools. And then also in this case we have specified a system prompt. You are an agent designed to answer queries over a set of given papers, so that it can make better informed decisions. And then again we are now querying this agent. Tell me about the evaluation dataset used in MetaGPT and compare it with SWE bench. So these are two research papers again. So now we will see how it is automatically going to first select the tool and then give us the summary of these papers. So as we can see in the calling function summary tool MetaGPT, it already automatically analyze which tool to use in case of MetaGPT. And for SWE bench, again it has selected the summary tool with SWE bench. So that is how smartly it is automatically selecting which tool to use and then selecting whether it be a vector tool or summary tool for each paper. So similarly we can see it with other examples. Compare and contrast LoRa papers, long LoRa and Loft Q. Here we are using summary tool long LoRa and then it is automatically using summary tool Loft Q. So overall in this Jupyter notebook we can see how we can query any of the research paper. If you have like different number of research paper that you can like input into this tool and query it, and also cross query between research paper.